Oh, good morning, everyone. My name's Rajesh Kunga. I'm from BSI. Welcome. Hope you're all having a good morning so far, and we welcome you to this webinar. Thank you for joining us. So as I said, my name's Rajesh Kunga. I'm a sector lead in transport and mobility here at BSI. My colleague Abby should be joining us, but she's my equivalent, but in the energy sector. I think she's having a few technical issues at the moment, but hopefully Abby will be able to join us a little bit later. The reason we're both should be hosting this webinar is obviously this webinar is around electric vehicle charging. Specifically today, it's on vehicle to grid. So we've got some great speakers lined up for you. But the reason it's kind of a crossover between transport and energy is because obviously electric vehicles fall into, on our side of things, the operations and charging infrastructure for transport, and then obviously the energy side where we're looking at more of the grid connections, charging safety, battery safety and storage. So like I said, today we'll be covering vehicle to grid, or as you may else know, by bi-directional charging. The reason we picked that today is it does seem to be quite an important topic currently, and obviously being a standards body, we've been approached by quite a lot of people in the EV community and industry regarding V2G and obviously standards. So after speaking with Energy Networks Association, who'll be joining us today, we talked about what topics might be relevant, and V2G was definitely one that was on top of our list of where we've been approached to look into things, do some more research around standards. There is work underway on international standard, which is ISO 15118, which covers vehicle to grid charging. That's currently being revised. Again, we have some speakers who will go into that in more detail a little bit later on. And there's also some new EU requirements for charging stations, which have come through recently, and that kind of means that charging stations will have to comply with ISO 15118 on V2G. And that could be as early as next year. I think they're looking at April next year. So like I said, we wanted to cover that off and maybe discuss what the benefits of vehicle to grid are, such as how it can help grid stability and resilience, how it contributes to net zero. Obviously, V2G can have economic value, particularly to EV owners and industry, and obviously encourages smarter infrastructure and innovation. So a bit of a spoiler alert, obviously we are BSI, as so the British Standards Institution, so we will be covering standards, but part of our role here is to convene industry and stakeholders. So actually the most important part for us in this webinar is to ensure that we are convening industry, as I said, and other stakeholders, and that we can all collaborate together, especially around V2G, which is fairly new, and hopefully, you know, pull people together so we could work effectively to achieve an efficient and kind of reliable V2G charging in future. So yeah, I'm not a technical expert on this, but like I said, we will be having some great speakers lined up for you. I'll introduce them in a moment. Could I have the next slide, please, Andrew? So I'll just quickly cover off on the housekeeping. So this is a listen-only webinar, so your microphones and cameras will be disabled on this webinar. So if you have any questions, please do put them in the Q&A section, which you should find on the top right with the little question mark. My colleague will be picking up any technical issues, so if you do have any issues, please drop that in the Q&A as well, and we have a couple of my colleagues keeping an eye on that, so hopefully they can get back to you if there's any problems. The webinar is being recorded, and a link will be sent out to you once you complete the feedback form at the end of the webinar, and also slides will be sent out as well. This is a CPT accredited webinar, which means it's been assessed and approved to meet specific standards for quality learning. So that can contribute to your own professional development. And if you want a certificate after this, then you just need to complete the survey afterwards. And there is a QR code there, which will take you to some of our other events which BSI are hosting. Thank you, Andrew. Yeah, so just quickly on the agenda. So we've kind of covered the housekeeping and things like that. So what else will we be covering today? So we are joined by Desnes, who will be providing the government overview of plans for smart charging and V2G charging, as well as what some of the government commitments are and benefits to V2G charging. We're also joined, as I mentioned, by the Energy Networks Association, who will be doing a joint presentation. So that'll be Mark Duncan, Mike Kay. They'll be looking at how energy networks are preparing for V2G, managing compliance testing, the potential impacts of V2G, and alignment with European requirements and standards. And last but not least, we'll also have an overview from a manufacturer's point of view. So Dev Rajstat from JLR is joining us. So again, yeah, giving us an overview of V2G from the manufacturer's point of view. And Dev Raj is also working on the revision I mentioned earlier on ISO 15118. So Dev Raj will be covering that. And then hopefully we'll have some time for some questions at the end. And I think just a quick note, I think the webinar might have said till 12, but we are aiming to finish at 11:30. So before we go to the speakers, I'll just want to give a quick, if I can have the next slide, please, Angie. Just a quick introduction to BSI for those who aren't aware of who we are. So BSI is appointed by the UK government as the national standards body. We were formed in 1901 and we are the world's first national standards body. We're a non-profit organisation and we hold a royal charter, and that reflects the magnitude and the importance of the work we do nationally and internationally across industries and society to facilitate innovation and help trade and consumer groups. Our role as the UK's national standards body is to help improve the quality and safety of products, services and systems, and that's through our development of standards and encouraging their use. And as you can see on the slide there, we represent the UK's economic and social interests across international standards organisations such as ISO, IEC, and also the European standards organisations such as CEN, CENELEC, and ETSI. And next slide, please, Andrew. Thank you. So just quickly, like I said, don't want to focus too much on standards on this one. We really want to jump in on the topic of V2G, and like I said, we have technical experts here who can speak around that more, but just quickly on the importance really around standards. So standards are an agreed way of doing things. They're open, consensus-based documents, and they're developed by thought leaders who share an interest in improving how things are done. So it's quite important for us. It's not actually BSI who write standards. What we do, as I mentioned earlier, is we're more of a convener. We convene industry together and get the experts into to develop and write standards. And what they should do is represent what good looks like in helping to make things work properly and improve the way organizations do things, and they support innovation, as I mentioned earlier, and complement regulation and policy. They're developed in a consensus-based approach, and that's, as I mentioned, with balanced input from interested stakeholder groups. So they should provide robust and trusted standards, which are all fit for purpose. And they also go through open consultations, which ensures that all interested parties have an opportunity to participate, and the process is all inclusive. We run committees with groups of technical experts to develop standards, and these are all, as mentioned, drawn from industry, government, research, academia, consumer interests, and they all volunteer their time to develop and maintain national and European and international standards. Next slide, please. So I just wanted to touch on probably a good example at the moment of one of our committees. Just go back one slide, Angie, thank you. And that's PEL 69. So PEL 69 is BSI's committee, which is a formal technical committee for electric vehicles. And the PEL 69 committee is responsible for developing and coordinating UK input into the international and European standards, as I mentioned earlier, and that's all related to EV technology, power transfer systems, vehicle components, and infrastructure. So you'll see in this diagram where PEL 69 feeds in on an international European level. So there's ISO TC 22, and that's feeding into electrically propelled vehicles and their propulsion systems. IEC TC 125, that's around personal e-transporters, and they provide solutions for transporting passengers and goods. It's IEC TC 69, and that focuses more around the electrical power and energy transfer systems for electrically propelled road vehicles, or EVs. So that's one probably in terms of on an international level, which is most relevant to V2G, which we'll be talking about today. And then there's CEN TC 301, and that specifies kind of the electric safety requirements for connections to electric vehicles. So a lot there, and you can see on the diagram some examples of international standards, and again, which PEL 69 feeds into. But the one, again, specifically we'll be talking on today is ISO 15118, which is in the top right, and that will be covered in more details by our speakers. Next slide, please, Andrew. So just wanted to cover off quickly on some of our key EV standards. So on this slide, you'll see that it highlights some of the key. These are more around the EV charging infrastructure standards that we have, and they come from the PEL 69 committee as well as the other international and European committees that I've mentioned. So these standards which support the EV market in regards to the uptake of vehicles themselves by improving consumer confidence and improving the rollout and reliability of charging infrastructure. As you can see on the slide, I've separated them into 5 categories, which are charging systems and connectors, vehicle to grid communications, power transfer, accessible EV charging, wiring regulations, and smart charging. As I mentioned, today will be more focused around vehicle to grid, but I just wanted to give everybody on the call just a bit of an overview of where you could find other EV standards. Firstly, in terms of the charging systems and connectors, there's the 62196 series of standards, and that looks at the interface between EVs and the charging station, as well as some of the general kind of mechanical and electrical requirements, such as tests of plugs, the sockets, outlets, vehicle connectors. And then there's the 61851 series, and that looks more around the electric vehicle supply for charging electric vehicles. And this also includes conductive connections, such as AC to DC supply, which I think will be covered later on by one of our speakers as well. So moving to the next category of vehicle to grid, again, as I mentioned earlier, that's the 15118 series, and that looks at how to enable grid-friendly charging, secure communication, and convenient plug and charge functionality. Again, I won't go into detail on that because we'll be covering that a lot more later. There's the 61980 series that looks at the power transfer for electric vehicles, and this one focuses more around the wireless power transfer, so the communication between EVs and wireless power transfer systems. There's PAS 1899, so this one looks at the accessibility of EV charge points. So we've been doing quite a lot of work around this, and working very closely and partnered with OZEV and the Motability Foundation to develop this standard, and that covers many aspects such as cable weights, bollards, space around the vehicle, screen heights, all obviously in the intention of making charge points more user friendly and accessible and inclusive to all. And then we also have 7671 series, that's around wiring regulations, so ensuring electrical installations are safe and comply with UK law. And then finally, we have the smart charging category, and that looks at energy smart appliances. So that's not just electric vehicles, but it does directly relate to electric vehicle charging infrastructure, as obviously they'll need to be smart. And obviously, we'll be covering smart charging in V2G in this session. There's a QR code which will take you directly to the landing page for that EV infographic, and there'll be more information on there. So please do visit that, and you'll be able to download that. And like I said, there's some more information on there for you as well. Next slide, please. I believe this is my last one. So just quickly, just wanted to cover off our BSI knowledge platform. So I did just show you some of the key EV standards, but obviously there's a lot more out there. So just wanted to put the link in there to BSI knowledge. So when you're on that page, either type in electric vehicles or charging infrastructure, and it should bring up more of the EV related standards, or you can go into explore by industry and go into automotive. But obviously just wanted to highlight this web page because not all of the EV standards are on the infographic there. So I think that's me. Next slide, please, Andrew. Yeah, so that's just my opening to BSI, and what we'll do now, as I said, don't want to focus so much on the standards and BSI. It's more around today around the V2G bidirectional charging. So I will pass on to Alex Gillespie, and he's joining us from the Department for Energy Security and Net Zero. So very grateful to have you, Alex. And Alex is a Senior Policy Advisor at DESNZ on EV smart charging, and also the government's lead on V2X bidirectional charging policy, and tasked with supporting the development and deployment of this kind of transformative technology and at speed and scale. So thank you for joining us, Alex. I'll pass over to you.
Thanks, Rajesh, and yeah, thank you to the BSI for having me today. As Rajesh said, my name is Alex Gillespie. I'm the UK government lead on bidirectional charging, also known as vehicle to grid, V2G, or vehicle to everything. And for those that aren't necessarily familiar with bidirectional charging or V2X, essentially it's this idea that EVs are just big batteries on wheels. So if we can connect them to the grid and make it so that they don't just take energy out of the grid, they can put energy back into the grid, or indeed into a home, then that unlocks lots of incredible benefits, not just for EV drivers, but for every energy user around the country. So my role is really about how can we make this new technology a reality? How can we integrate it into our energy system, and how can we do that at speed and at scale? I guess just briefly to say, I am part of DESNZ, but I am also part of OZEV, the Office of Zero Emissions Vehicles, which yeah, is a joint partnership between as was here, between DFT and DESNZ. So as you might imagine, yeah, I work very closely with my colleagues at DFT, pushing forward V2G and pushing forward that agenda in the UK. And my broader team also looks after smart charging. Today, I just wanted to speak. I'm a policy maker. I'm not a technical expert. I'm not an engineer. We've got some colleagues on the call here, some experts who will know much more about the technical detail of this stuff. But I guess I just wanted to give a brief overview on what the government thinks the benefits of V2G are and how we think that can contribute to some of the key government missions. And then I guess to talk briefly about the importance of grid connection and what that means for V2G as opposed to, potentially smart chargers. So yeah, I think, yeah, we see V2X, V2G as, I guess, the next evolution of EV charging. So if we've moved from kind of very standard charging through to smart charging, and now all charge points have to have an element of smart charging capability in them, I think V2X is the next evolution of that, and we think there's massive benefits to that technology. From the individual level all the way through to the kind of global level. I won't talk through all of these, but yeah, obviously at individual level, there's a big opportunity there to provide another kind of revenue stream if you're selling energy back to the grid, or if you're making better use of your solar electricity, then you're helping reduce the bills of those EV drivers, which supports the EV transition. And this goes all the way up to globally, and I think Britain is a global leader in both the EV transition and the clean energy transition, and we're very much leading the way on that. And V2X is another kind of feather in our cap that helps support that leadership that we have in this space. So we mentioned smart charging, and I thought just touch briefly about how we see EV smart charging as complementary to V2X. And that kind of mechanism by which we can help flatten demand, which is the kind of real main benefit of these technologies. So if you see here, the kind of yellow part of the bars is the EV demand over time, and obviously that kind of classic spike around 6 o'clock when people are coming home. If we have smart charging, then what we're able to do is kind of move some of that demand from areas of peak demand into times where there's much less demand, and when there's kind of more renewable energy in the grid. So you make charging cheaper, and you make it less carbon intensive, and that works in a complementary way with V2X, which actually allows you to play a more proactive role in reducing that demand as well, by kind of releasing stored energy, or you can imagine selling stored energy back to the grid during those times of high demand. And the end effect of that is that we reduce the overall kind of demand. We spread it more evenly across the day, and I guess that's the key mechanism by which we help reduce the cost of charging and enough energy, and we help kind of decarbonize the grid quicker, because in the short time we're not having to use so much short-term generation like gas generation to meet that demand. And over time, that means if we can be meeting more of our demand through smart charging and through V2X, then that means less infrastructure build out, less demand, less generation build out, and that will save cost of the grids over time and save cost to taxpayers, not just all kind of energy users, not just EV drivers. So when we talk about that kind of flexibility potential, we talk about the amount of kind of flexibility, energy flexibility these technologies can provide to the power grid. And I think just want to point out here that our friends at NESO do lots of regular kind of projections into the future in terms of where is our energy generation going to come from under different scenarios. And their most recent report had a number of different scenarios, but had this incredible stat of a potential for 41 gigawatts of flexibility capacity coming from V2X by 2050 under their holistic transition pathway. That's an incredible amount of energy. Just by way of an example, that's the same as 10 plus, the output of 10 plus nuclear power plants. So that'd be an incredible amount of demand being met by V2G in the future potentially. And I think there are the scenarios that have that smaller amount, so obviously this should be taken with a pinch of salt. But I think what's exciting about this for me is it kind of demonstrates the potential of this technology. And worth saying here that these are not DESNZ numbers, these are NESO numbers. We're currently working on our own projections for V2G and how much we think it can provide to the grid, both by 2030 and onwards to 2050. So yeah, in summary, I think we've got this kind of small but or should I say nascent technology. Jump forward on too much there. We've got this kind of nascent technology which feels potentially quite niche and quite small at the moment, but could play a really outsized role in making the UK a clean energy superpower, both through supporting the development and deployment of clean power 2030, potentially starting with a smaller amount of flexibility. I think the latest NESO projections was up to 1.2 gigawatts. So starting with a kind of relatively humble amount, and then that really potentially accelerating towards 2050, where there's, as NESO said, up to the potential of 41 gigawatts. So supporting those elements and those pillars of the clean energy superpower mission, whilst also supporting our growth mission, obviously hopefully reducing bills and supporting this new kind of emerging clean energy sector and the businesses and jobs that go with this. And I think the exciting thing for us is it feels like V2X is here, or very almost here. It feels like we're on the crest of a new wave of propositions. I was slightly reticent to put this slide in because I think there's probably been someone like me on a webinar like this for the past 5 years saying that V2X is here. I think we've had some false dawns in it, but it does generally feel to us in government that that there's a new wave coming, and the kind of tie up between Octopus and BYD really kind of firing the starting pistol on a new wave of propositions coming to market. I think based on our conversations with the market, we hope optimistically that there will be, by the end of 2026, 4, 5, 6 plus propositions in market, which is obviously incredibly exciting to see this technology become tangible again, and hopefully tangible at a broader scale, and seeing it demonstrate at a broader scale. So very excited for that. So moving on to talking about, I guess, grid connection and what that means for V2G. Yeah, I think we are committed as government to supporting the deployment and the uptake of V2X. So those are my two kind of key objectives. And the deployment being making sure this technology is ready and usable and widely available commercially for people to pick up and use. And the uptake being the side of, you know, is this technology easy for people to use? Do they know about it? Are they interested in picking up and using it? So those are the kind of two sides of the of our kind of policy objectives. And as you might imagine, you know, making sure V2X systems can get connected to the grid quickly and easily is vitally important to realizing those government objectives and making sure we can roll out V2X at speed and at scale. I think obviously goes without saying that connecting V2X to the grid is a different proposition to connecting a standard charger, which is only capable of taking energy out of the grid. If we've got a system that can put energy back into the grid, there's a lot more requirements that go into that. Lots of safety requirements, as our colleagues will speak to later, especially Mike from the ENA. But yeah, it's a different kettle of fish than normal charging, and we need to make sure that we're obviously getting these things connected to the grid at speed, but we're also ensuring stability for the grid now and in the future. I think for us, from a grid connection point of view, we've got two kind of objectives, one short and one kind of medium term. So I think in the short term, we want to support, you know, in the last slide I talked about V2X systems coming to market. We want to make sure those systems can come to market as quickly as possible, make sure they're grid ready so that they can be connected easily and simply. In the medium term, we understand there is more kind of fundamental technical challenges that come about from, I guess, the combination of the vehicle to grid and you know, the grid connection processes. So yeah, we need to work through those collectively, and I'll speak to more of that shortly. I guess just briefly from my kind of simplistic view, just want to talk about the kind of two parts of the process. So largely the kind of grid connection process for VTG is done through the G99 kind of technical requirements, which comes out the ENA. There's kind of two parts of that in my mind. So one is the kind of certification or type testing side of things. So getting vehicles or chargers onto type test registers, so they've been tested and made sure they are robust and ready to connect to the grid. That is a kind of optional part of the process, but I think it's an important one to make sure that you know, installation is much simpler and easier if your device is on a type test register, either kind of centrally or with the DNOs. That makes the process of connection much easier, and you only need to do that kind of once per hardware model. I think we're aware of there's a number of kind of V2X specific challenges with that we need to kind of think through and work through. And then there's kind of the installation side, so getting this thing in the ground and connected, and that's obviously the kind of core part of the process that's done every time the charger is installed. I think we're aware there is some potential V2X specific challenges with that, but I think there is more, as this speaks to more broader challenges with EV charging and connection in general. I guess there's lots of colleagues working on that more broadly. You know, I'll point you towards the Ofgem connections, end-to-end connections review, which is currently in process. And in December 2024, DFT published the outcome of a review, which was all about kind of improving the grid connection process for EVs, and that the actions out of that are kind of ongoing. But for me, as a V2X policy person, I'm very interested in the type testing side of things. How can we make sure this hardware, this V2X hardware, and these V2X systems are ready to connect, whilst also feeding into the installation side of things, and yeah, seeing if there's specific challenges with V2X that we need to feed into, and certainly feeding into those other projects that are helping solve some of the more broad issues. I think the guys at the ENA will speak more to this, but yeah, the ENA's Connect Direct platform, I think, is really important in terms of simplifying the, I guess, both sides of that that process. So there's a central, like Connect Direct has a centralized type test register, which has V2G as one of the options. And I think from our point of view as a government, it feels like it makes much more sense for there to be one centralized view of all the kind of approved devices that the DNOs, each of the DNOs can then reference, as opposed to potentially going to each individual DNO and getting on their type test registers. So I think if you are a car manufacturer or charger manufacturer, it would encourage you to try and go through the Connect Direct process and get onto that type test register. So there's a central kind of register of all those things. Just briefly on the final couple of slides. So I think, again, coming from a policy point of view, not a hardcore technical point of view, I think for us, there's, in terms of getting on those type test registers, or getting assessed and getting certified, there's kind of three approaches in my mind as it stands. So one is DC V2X, where that inverter is in the charger. That certainly simplifies things from I guess a grid connection point of view, certification point of view, because all the important stuff is in the charger, so we can just kind of certify that charger or focus the certification on that charger. And also with emerging kind of what we call kind of closed loop AC V2X systems, so that is systems where there's only one car can work with one charger in terms of its V2G capability. That creates a kind of closed loop system that allows you to kind of certify the charger and car like as a combo. And I think with both of those approaches, our understanding is that they're both possible within the current G99 guidelines. There may be some kind of requirements required, and or some kind of better guidance to help guide people through this. Obviously, it's a new technical area, and definitely some challenges there. But takeaway, as I understand it, is that should be possible. I think where things become slightly more trickier is with interoperable AC V2X. So that's this idea that any charger could work with any car in terms of that V2G capability. And there's questions there about, do we certify the charger and car independently? What does that mean? And I think there's like much more fundamental technical challenges that need to be considered, and obviously being considered at a European level as well, which we're keeping a close eye on. Finally, I just wanted to point you towards a clean flexibility roadmap, which is essentially the roadmap for all things energy flexibility, including EV smart charging and bidirectional charging, and lots of different actions we're taking as government to push forward flexibility, and lots of key actions along that. Just pointing you towards two of those actions in that roadmap. So the first is around grid connections and how we might be able to improve those processes and interoperability. I think, we're very keen to work with industry, to work especially with the people that are, trying to find their way through these grid connection processes, and alongside the ENA and DNOs, obviously, to kind of work together to I guess centralize any issues we're finding, work through any issues collaboratively. So if you want to talk on that, then please feel free to reach out to me, and there'll be more in this space coming in the coming months. And then finally, today is a lot about kind of standards, and we're very aware there's lots of standards governing lots of different communications aspects between EVs and between charge points, as well as energy suppliers, aggregators, the whole kind of ecosystem. And we understand it's important for the government to have a view on those, and when we are potentially going to adopt them, where and when we align with the EU in terms of their adoption of key standards, with things like ISO 15118-20. So just to say, another key action for us coming out of the Clean Flex roadmap is that we're going to consult on a lot of these standards in early 2026, and different approaches to them. So another one to look out for. V2X, incredibly important. grid connection for V2X important as well, and in enabling and making that a reality. Some challenges to work through, and yeah, as government, very keen to work with industry through those challenges over the coming weeks, months and years. So that's me, thank you.
Thank you, Alex. That was really, really helpful and useful information there on what the government are doing around V2X, some of the commitments. But it was great that you highlighted the challenges and how we have to work together moving forward. So not just standards, but like you said, just collaborate with other industry experts around this area. Also, like you covered some of the benefits there for the consumer. So that's a really interesting point as we move forward. Obviously, the average kind of consumer will of an EV users will need this to be quite simple for them moving forward. So again, another challenge in itself, but yeah, really great to see the government are on top of that and aware of that, and you know, we look forward to working together to resolving some of these issues and moving forward on it. So yeah, I'll pass over now to the Energy Network Association. So joining us today is Mark Dunk, and Mark is the head of engineering and resilience at the ENA. He has 30 years experience in civil and electrical engineering and started with the ENA in 2018, and Mark currently manages the industry technical and resilience standards and guidance for plant and equipment assessments and the distribution code. And Mark is joined by Mike Kay. So be doing a bit of a double act for us. And Mike is a chartered electrical engineer and fellow of the Institution of Engineering and Technologies, IET. He has expertise and experience covering all aspects of power engineering associated with distribution and transmission of electricity. And Mike currently works as an independent consultant, and one of the roles includes advising the ENA, hence why Mike's joining us today. So I'll pass over to you, Mark and Mike. Thank you. Thanks for joining us.
Thank you, Rajesh. Yes, if we can go on to the next slide, please. So yeah, Mike and I are going to do a little bit of a tag team this morning. So I'll run through the sort of where ENA is approaching the compliance process for vehicle to grid connections, and then Mike will look into or provide more information around sort of future standards, what's happening in Europe, and really kind of what we're hoping to sort of pick up on as we develop our processes here in the UK. So as Alex has alluded to already, vehicle to grid or vehicle to X is here. It is actually here now. We've been talking about this for a number of years, and it's always been a bit of a far off concept. We were aware of what, you know, how EV charging has developed, from Tesla providing on-street charging only for Tesla cars to now having a common standard for, you know, any charger in any electric vehicle. Ultimately, we'd like the same for vehicle to grid, but we're not quite there yet. So we've been monitoring what's been happening in the vehicle to grid arena, if you like, and fairly confident we had it all in hand up until probably about 12 months ago, and started to see development of vehicle to grid enabled products from Octopus. And as we've since found out, they're working in partnership with BYD to develop a package that can actually be delivered, then a commercial package for customers. You buy the car, you buy the charger, you get the electricity and so forth, and it's it's a good process. We're also, over the last, certainly this year, seeing offerings from Renault, Nissan, also in Audi, looking to sort of trying to bring products to the UK market. We appear to sort of be a bit of an enabler, if you like, you know, they're coming to our market while everybody's discussing things in Europe and going, we would like to effectively quite, you know, almost trial the systems, but actually in a commercial environment. So where does that leave us as electricity networks? We need to make sure all that's being connected to the network is compliant with the electricity distribution network requirements. And we do that through a series of standards and documents. If you go into the next slide, please, we'll talk a little bit around the key one on that. So effectively, our main document, if you like, is engineering recommendation G99. It's been around since 2019, as you can see, and it stems from the changes in the requirements of generators, the European requirement for generators, which came out in 2016 or thereabouts. And fundamentally, it's focused on connecting generation to the network. It's a distribution code document. It's one of about 20 or so documents that form the sort of technical guidance, technical compliance of meeting the distribution code and hence the distribution license requirements. And therefore, it's mandatory and enforceable through the distribution code. Networks have to comply with the distribution code, and as such, they will ensure that anything connecting to their network does so too. To have something that's not meeting the requirements of G99 and its supporting documents would mean there'd be non-compliant generation on the network, which would mean that the distribution network operators would also be non-compliant. Nobody wants that. We get a slap on the wrist from Ofgem or worse. So that's why I'm talking around this document. It's fundamental in understanding how generation should connect to the network. And why are we talking about generation? Well, batteries operating on a network are considered to be generating when they're exporting, and as such, vehicle to grid enabled vehicles, yes, effectively considered to be batteries. Therefore, when they are exporting, they are generators. Therefore, they need to comply with G99. If you could go on to the next slide, please, we'll continue to work through it. So, going into a little bit more detail now, and really starting to look at the compliance process that ENA is working to develop. We have systems in place which enable us to assess EV charge points. We have processes in place to allow us to assess the compliance of inverters. And until now, they've been very much separate things within Connect Direct and the type test register, which is hosted within Connect Direct. And you heard Alex mention Connect Direct previously. With a little bit more detail on that, really, is it's a database of approved equipment. So we've had EVs, charge point manufacturers submit their offerings to us to be included on the EV charge point approvals list. And there's really some fairly basic checks that happen with that. And then the slightly more complicated process is the type test register for inverters, effectively for sort of connection devices, where we assess them for G99 compliance, G98 compliance as well. But for the purposes of vehicle to grid, we'll focus on the key topic of G99. So we have these two processes, and what we're currently trying to do is bring them together. So we'll cover this bit. Yeah, sorry, I do. So the offerings we've seen from Octopus BYD, from Nissan, from Renault, have taken a bidirectional connection device, easy for me to say, and a vehicle to grid enabled vehicle. And between the two of them, they form that compliant connection. They have to operate together. And we'll go into a little bit more detail when Mike brings his piece in of what we would like to see from Europe, we'd like to see from standards regarding individual compliance of those two components. But for the time being, and for the purposes of the type test register, the purposes of Connect Direct, we are looking to see how we will assess those two units operating as one. So we look at really kind of harmonics from the side of point of view of the demand connection. Not expecting a huge issue, but it needs to be checked. And so this is really more for sort of making sure that when the switch is thrown, there isn't an impact on the network. There isn't something pushing back out onto the network, causing fluctuations in the network. And we'll check through against various technical standards, including the one you can see there, 61851, part 1. But more for us, and more sort of the part that has the greater impact on the network, is for when that battery, when that vehicle wants to discharge back out onto the network. Really sort of a commercial offering. And as I say, we've got some pre-assessment checks that we would expect manufacturers to provide information around. And as part of that form A2-3, you can see there's some technical information that we'd expect from the manufacturer. As I say, we need to adapt some of the forms and some of the processes. At the moment, the generation form is location specific, and it's not. And as vehicles become, or vehicle to grid becomes more mobile, if you like, we will recognise the fact that that unit, once it's confirmed compliant, could end up anywhere on the network, and that provides us another particular issue around that. But we'll come to that in a moment. So if you can move on to the next slide, please. Ultimately, what we're trying to do is work through how that generating unit, that small mobile generating unit, will engage with the network in a positive way. It's making sure that it doesn't do anything that we don't want it to. It's not going to sort of start causing fluctuations in the network. It's not change frequency, voltage, and all that sort of thing. So there's a list here, and the numbers in the brackets there are the relative clauses in the type A section of G99. And effectively, you can see here, you know, what we need to be done. We still need to retain that control by the DNO. It's essential that we can do that, because if there are fluctuations in the network, we need to be able to protect it. G99 is about protecting the network. It's making sure that it remains operational with everything that's connecting to it. And it's about, and what Mike and I are trying to do, or are progressing at the moment, is bringing forward all of these requirements that we would need from vehicle to grid, and don't take this the wrong way, in an easier to read format, something that's really kind of up front and provides that information. If you want to do this, these are the rules, the regulations, the whatevers that you need to meet. So we're also looking for standard interface protection systems, as again set out in G99. It's about making sure, again, frequency, the voltages, and everything like that are all operating. The vehicle, or the unit, if you like, operates and can operate in those within those thresholds. And we're looking at power factors, obviously, standard generation plus or minus 0.95, and again, operating within that frequency bound. If you go to outside that frequency, again, you get that impact on the network that's not desirable at all, and ultimately, if sustained and large enough, can then start to have a runaway effect on certain on the network, and ultimately we end up in a black start situation. Not suggesting a single vehicle grid can do that, but you have to consider what the possibilities are, and also potentially when you start to get closely connected, also geographically connected vehicle to grid units, for example, a car park, lots of people are in there. We need to consider the impact on the network. It becomes a much larger potential generation source. That's why we continue to kind of build on this. You see that there's a requirement from March next year to have LFSM under response. And obviously we've got the same thing for the over frequency response as well. And again, we're touching on sort of future things here, is whether we want to sort of have reactive power control. Not at the moment. Again, we're not seeing the volumes of vehicle to grid, still very much in its infancy, but it's something we need to consider as an industry, make sure that we are thinking ahead. We're very much over the years been dealing with the problems as they are. There we go. It's always a problem. Let's try and design something. Let's try and build something. Let's try and put some policy and guidance in place to address that problem, which is now 6, 8, 9 months old. We're now starting to look at a lot more ahead. Could this be a problem? If so, what should we be doing about it now in order to make sure we've accommodated it? Can we be more flexible? Can we change the ranges, the thresholds to make it easier to connect? Or indeed, do we need to make these requirements more robust to ensure that absolutely, you know, this type of thing, the impact cannot happen or should not happen? And it gives us that option then of, you know, for non-compliance, for disconnection of generation and so forth, where it's necessary. So I talked about G99. There are also A couple of other key documents for generation, one of them being G5, which is the harmonic distortion, sort of harmonic voltage distortion. Again, mentioned sort of harmonics and things like that from the demand side of things, also an impact from generation, and likewise voltage fluctuations for under P28. So they're relatively complex documents, relatively technical, and it's again about us being able to provide that guidance in a way that's understood by intelligent operators, intelligent customers who want to connect to the network, but aren't necessarily network engineers, aren't necessarily involved with the design of the network. So they need to have a bit of an understanding. Again, that's what we're working towards. So go on to the next slide for us, please. I want to make sure we're keeping things ticking along. So what's the point of all of this compliance assessment? What are you going to get out of it, and why are we doing it? As I say, we're doing it to protect the network. But ultimately, from the customer point of view, or sorry, the manufacturer's point of view, is where we've assessed a vehicle to grid offering, EVSE system, where it's compliant with both the demand and the generation requirements, we will provide through the type test register a single system reference number. Now, currently, we'll have a system reference number for the EV charge point. We'll have a system reference number for the inverter, and never the twain shall meet. They can sit around floating around in their own little bit of the ether, and potentially, if you're doing a vehicle to grid enabled connection point, you'd have to identify a specific inverter with which to sort of combine those two, and that would form part of your submission. Where we're starting to see the vehicles and the bidirectional connection points working together, the intent is to assess them, as I say before, in a unit, and from that we'll be running through a single system reference number within Connect Direct, which then enables those manufacturers, those suppliers, to say to their customers, this unit is being shown compliant. When you want to connect to the network, as in you're particularly at home or you're connecting to a like-minded bidirectional connection device, this is the system reference number you will use. The advantage then for the DNO is they know that compliance check has already been made. They know that providing it continues to operate within the bounds that it was assessed within, it will not have a negative impact on the network, and will start to build on those positives and those demand curve flattening, the support of the generation, support of the network that Alex was referring to in his submission. So bit of a quick run through on that. There's a lot of information to get across, but the process is there. We just need to tweak it a bit to make sure that it does what we need it to do from the point of view of the network operators, but also that information is available, and we'll build on that over the next couple of months, and we'll look to update our web pages and our guidance and so forth as we do that. So if you're okay, Mike, I will hand over to you and sort of allow you to sort of take us through what's happening in Europe, what's happening with the standards and future systems.
Okay, thanks very much. On this slide here, we're just trying to demonstrate the main standards which we understand to be relevant to this, and really want to sort of focus on the interoperability question. Alex mentioned earlier about all the actions the government intends to take to help overall interoperability, but I think we probably need to split interoperability into sort of two parts. There's the wider general interoperability in the market, so that customers can get the benefit of using the capabilities of vehicle to grid by selling services from that, or having relationships with their supplier, and that clearly all needs to be interoperable in the future. But more narrowly, there's the question of the interoperability of the grid compliance requirements, and this is just between the charging equipment and the vehicle. Now currently, as Mark said, because we don't necessarily understand the design of the vehicle and the charging equipment in detail, we have to consider them as a unit. And this is particularly an issue for AC. The DC interoperability challenges much less. But for AC, where the functions that are required by the grid codes and G99 could be either in the charger or in the car, that's an issue. But going forward, we believe that when these standards, all these standards are under review right now. And if you just show the next slide, I've got a table with some of the actions that are ongoing here. It's our hope that when these standards are all rewritten to cater for the future, and particularly interoperability, then that will actually enable everybody to treat the AC charger and the AC vehicle separately, because they'll be manufactured and tested to standards which guarantee the interoperability. Now, I'm not going to go through this in detail, but you can see the main standards that we understand are important listed here. But in the last column, you can see the dates of when these documents mature. Now, although the sort of final approval for some of these might be still a year or more away, as we understand it, and I'm not actually an expert in the evolution of standards, but as we understand it, the drafting stage they'll all get to by probably the middle of next year, 2026, means that we will effectively have an infrastructure arrangement whereby manufacturers should be able to manufacture to these standards, and we'll actually have the start of interoperability, true interoperability for AC connected vehicle to grid EVs. So we know this work is going on. Some of us are getting regular updates on it. It all sounds fairly positive, but with all these things, of course, nothing is certain until everything gets signed off. But if you move on to the next slide, please. A lot of the developments in Europe, I think, are actually really helpful here, because apart from the international standards being revised, the EU Commission is planning to update the existing network codes. Now, these, of course, will probably not directly affect us as we're no longer in the EU. But to the extent that it drives European manufacturing or manufacturing for the European market, it's hard to imagine that we wouldn't get some benefit by adopting the same approach, particularly since we have the same challenges. So the implications for EVs are that, they're not great, but all the EVs will need to comply with frequency response characteristics. Now, this is actually new in European law, but as Mark outlined a few slides ago, this is the LFSM-O and LFSM-U, which are already in G99. In the network codes, there are some aspects that don't apply to EVs, so we can ignore those, but most of the revised requirements will apply. But another very valuable point is, at least in Europe, that the requirements are actually harmonized. The current EU network codes allows for every member state to have slightly different requirements. And that's still true in general, but not for EVs. The requirements have all been harmonized. So to the extent that those requirements are applicable in GB, and this is something we are still looking at, that might make things even simpler in terms of us being part of a larger market. One thing that will remain different is the interface protection, which Mark also mentioned. But the standards that are being developed put the interface protection into the charging equipment, i.e. the fixed equipment. So that again allows the sort of certification aspects of this to be done on a local basis, which is more or less where we are now. So that's not seen to be a problem, even though it's a remaining national difference. It's also probably worth saying that all of these requirements really relate to system abnormalities, i.e. they are the behavior of the EV and the EVSE when the power system is stressed and working way outside its normal operating characteristics. These kind of events happen once or twice a decade. It's that kind of frequency, and that's when the system is being stressed. That's when it's really important to have the right response, the right behavior from all these electric vehicles and all other generation. So, but day to day, these technical requirements should provide absolutely no inhibition or restraint on how customers use their electric vehicles, nor how they sell their capability to the wider markets. I think the last thing that's helpful on top of the standards being developed is the new EU law will actually require that EVSE, the charging equipment, and the vehicles are all interoperable. So that actually becomes a legal requirement, which means although the standards may not be mandated, in effect they are mandated, because by law it all has to be interoperable. And I think that's all I wanted to say. So thank you very much.
Thank you, Mark and Mike. That was really interesting and really great to hear about interoperability. Hopefully I'll get a time. I think that'll be one of my questions going in there, but also great to hear about the update on European standards, and that we're already thinking about what's required, and looking at compliance assessments and things like that, and protecting the network and what rules and regulations are going to be required moving forward. So yeah, really interesting. So thank you again. I'll pass on to Devraj Dutt now. So Devraj is a technical specialist in EV charging systems and vehicle-to-grid technology. So it's really great to have your experience joining us here, and your knowledge, Devraj. So Devraj is currently serving as a V2G group lead and technical specialist at Jaguar Land Rover, and looking at next generation EV platforms. And Devraj contributes to committees such as I mentioned earlier, such as IEC TC69 and ISO TC22 on EV charging related topics. So and I think Devraj, you also represent for BSI as well for them committees, which is great. So yeah, very glad to have you here, and I'll pass over to you, Devraj. Thank you.
Hello, thank you so much, Rajesh. I hope you can hear me. Yeah, so I'm going to take you through some of the more basic concepts about V2G, since I'm mindful that the audience of this conference, it may not fully be up to speed with all of the strange terms and things like that used. So we're going to start quite basic with the first slide. Could you help me with the next? Okay, no, I think it was. So vehicle to grid is just power transfer from the vehicle back into the grid. But one of the key things that should be understood is that there are two terms. There is one that is vehicle V1G, and one is V2G. So what V1G is basically what all electric cars already have been doing for the last 10 years or 15 years or so, since the first leaps and so on came about. V1G is just the transfer of power and energy from the grid to the vehicle. So it's unidirectional in that it only accounts for energy transfer from the grid into the vehicle. And V2G is then bidirectional power transfer across on both sides, so from the vehicle to the grid or from the grid to the vehicle. There's a definition generally of V2G that we use, that's up on the slide for your benefit. If we look at why V2G, or what it does for the consumer specifically, not thinking about all of the other benefits that some of the speakers have mentioned before about grid stability and all of those aspects. If you were looking at it from purely a consumer perspective, These are some photos from the US where Tesla actually sent out a check to customers when they earn money for V2G services. So this is a very tangible aspect of how customers can actually make uh, some money by not doing anything other than having their cars parked at the charger. So basically, you have the possibility of having energy savings, doing energy arbitrage, offsetting when you actually use the energy by based on time of use tariffs. And there are also certain energy operators in the UK, for example, and also now in Spain and France, who are offering these contracts where if you have an electric vehicle and park it at home and charge it at home, you get all of your electricity for free. So those kind of lucrative things are happening, especially in countries like Norway and Sweden, where energy is very expensive, or uh, also places like Spain and the UK, where your energy bill could be quite high. There are some things you need to do to get V2G at home, which would be which could span from just installing a charger that supports and having a car that supports V2G, all the way up to upgrading your electrical meter and how many ways it can register the flow of electricity, etc., and also the the connection to the house or the building where you are installing um, the V2G charger. However, once all that is done, if you just park your car, there are significant benefits to be had. Okay, one second. Okay. I put up some classifications of V2G. So basically, you could classify it by energy type, by standard, and by implementation. Um, some of the things that have been mentioned during this talk about some of the OEMs already providing V2G in the UK and some other parts of the world like France and Germany have uh, the key thing to remember about those implementations is all of those implementations are proprietary implementations, which means that um, the vehicle that is sold to you and the charger that is sold to you are the only ones as a match pair who will do V2G. So that means that if you and your neighbor have the same vehicle and the same charger, there are chances that even if you charge at your neighbor's place, you will not be able to charge to discharge into the grid. Also, as an OEM, when we look at V2G, we always have a bit more of a global perspective. So, we are looking at not only the UK, but what we need to do uh, for the rest of the world, and there are other parts of the world like China and Japan, uh, which then have their own standards, not that don't necessarily match up to what is prevalent in Europe and the UK and North America. Um, so China has GBT plus now, a new standard coming up, and then the oldest standard which actually supports V2G natively has always been CHAdeMO, which is quite common in even in the UK with old Nissan Leafs and so on, but that's primarily a Japanese standard. Um, and of course, by energy type, we will talk about that on the next slide. So when we say ACV to G, it means that the energy transfer between the charger and the vehicle happens with AC. And when we say DC V2G, it means that the energy transfer between the charger and the vehicle is done by a DC connection. And then, of course, the grid is always AC. So that means that in the first case, with AC V2G, the vehicle is the inverter, which then converts the energy from DC to AC before putting it into sending it over towards the charger. Whereas in the case of DC V2G, the charger is then the piece of equipment that is switching the type of electricity from DC to AC. Whereas on the vehicle could just be seen as a battery pack effectively. So when we talk about AC V2G and DC V2G, there are some advantages, disadvantages, comparisons. As we've discussed, the conversion type, energy conversion is happening on the vehicle in case of AC and on the charger in case of DC. Also, a lot has been said about grid codes and compliance. When with AC V2G, as one of our colleagues from DESNZ was saying, we have to make sure that both the vehicle and the charger are working as a matched pair. A future step to that could be that the vehicle and the charger are certified separately. However, that is something to be discussed and perhaps coming in the future. But in case of DC V2G, the vehicle is a battery pack, which publishes certain limits to the charger, and then the charger is responsible for fulfilling the grid codes while respecting the limits that have been published by the vehicle. Also, if we think about efficiency, what we always look at is the battery to grid efficiency. And in the case of AC V2G, the power conversion device is on board the vehicle. If you put anything on board the vehicle, there are significant losses in efficiency, for example, because of less space, so smaller components that run hotter with a sub-optimized thermal behavior, etc., etc. So what basically happens is the overall battery to grid efficiency is generally much better if the power electronics are off board the vehicle rather than on board it, because of the fundamental challenges in putting something inside the vehicle where you have space constraints and thermal effects, etc. As far as the equipment is concerned, if you think about building a vehicle with AC V2G capabilities, you have to have good power electronics on board, and the vehicle's onboard system, including the software and the hardware, has to support all of the grid codes where in the countries where the vehicle will operate in. Whereas if you think about the DC V2G case, it's only the charger that takes care of all of the power conversion. So the charger is definitely more expensive in case of DC V2G. However, in the case of AC V2G, the customer pays for the capacity to do V2G irrespective of whether they actually do it or not, or whether they have the capability to do it in their home, etc., or not. So, for example, if you live in a flat on the 10th floor and do not have a charger at your parking space, you would be still paying for the AC V2G equipment on your car, but you wouldn't probably be using it unless you find a public charger, which is currently not the the common track for certification as well. So yeah, if we look at what standards are relevant globally, you have these. So in the EU and also kind of quite similarly for North America as well, you have these standards applicable. Um, the 61851-23 is for DCV2G, and the 61851-1 is for ACV2G. The additions are important because the earlier editions do not support, do not have information about V2G. And the 15118-20 works quite well for DCV2G, but there will be a new amendment to then include the ability to communicate certain aspects of the grid code from the charger into the vehicle, which is currently not fully supported by 15118-20. There is another standard, which is the 17409, which transfers into the ISO 5474 series, where you have 5474-2 and -3, which are applicable specifically to the vehicle. However, the core of the content of those standards is just references to other standards, more or less. So the meat of what's needed is actually in 61851-23 and 61851-1, and then the ISO 15118 for the communication. And then, of course, other specific grid codes that may need to be applied. In China, you have the GBT standards, the GBT 27930, and then the 18487 versions. And then in China, you also have a specific standard for V2L and V2V, which is not directly V2G, but there have been some implementations where an off-board charger has been using the vehicle's V2L capability to then do V2G. So that's interesting to know. And then in Japan, you have CHAdeMO 2.0, which is quite fairly well known. This is how V2G actually works in 15118-20. This is, of course, the DC part of it. So as you can see, the charging is split into different zones based on the onboard energy level of the vehicle. And then basically you have this zone 3 where you are able to go up and down. So basically the charger decides when to draw current from the vehicle and when to put back current into the vehicle. But this is done within certain limits. So the vehicle always provides the charger with a maximum charge and discharge rate, and then of course also these limits to where zone 4 and zone 2, as well as zone 5 and zone 1 starts, are provided by the vehicle. But then, as you can see, as long as the charger maintains the charging session within zone 3 for a long enough time, it's easily possible to then treat the vehicle as basically a stationary battery pack. And that's where that's the advantageous area where V2G happens. I think we have a slide on regulations. So all of those were standards that we spoke about from the standpoint of regulations. We've got 15118-20, which will become mandatory for all new charging stations from January 1st, 2027. However, 15118-20 will not be mandatory for vehicles until further notice. There's also 61851-23 edition 3, and probably that one will be the one which will get included in what is called the European Commission's low voltage directive, which then becomes a legal requirement to fulfill. I believe 61851-1 is also in line to become part of that. Some OEMs have started doing V2G in some parts of the world, either by pilot projects or by publicly available vehicles. None of these have currently the capability to fulfill everything from a regulatory perspective in terms of what is becoming mandatory. And it's important to understand that the path to DC V2G in terms of a completely interoperable solution that you could deploy in Japan as well as the UK or the US or Brazil will be much simpler, because the vehicle then does not need to manage the grid codes, and the grid code compliance can be locally done at every EVSE that is installed in the location, using just the basic standards available. However, if ACV2G is needed, a lot more work needs to be done to achieve something which is truly global from an OEM perspective. So all of the OEMs that I've interacted with will only roll out V2G in certain parts of the world. Start with 2 countries, 3 countries, 5 countries, and then go from there. So if you are in one of those countries and if you bought an ACV2G vehicle, you will not be able to use that ACV2G capability if you drive to another country, for example. The grid code compliance for ACV2G using 1511A-20 is important for ACV2G, and that is also not yet released, but 1511A-20 Amendment 1 is going to be released quite soon. There was a slide in the presentation before about when in time this is expected. So with that, I've come to the end of the presentation. Thank you so much. Over to you, Rajesh, to go to the Q&A session, and thank you for the opportunity.
No, thank you, Devraj. Really interesting stuff there, especially having that information come directly from a manufacturer. Really interesting things there around, particularly the differences between AC and DC, and again the differences with standards coming from China and Japan, and how we have to kind of try and align them with the differences in Europe and things. So yeah, we have a little bit of time for questions. So it was actually one unfortunately Alex won't be able to join us for the Q&As, but Mark and Mike, if you could pop your cameras back on, if you're happy with that. And also my colleague Abby can't join us, had some technical issues today, so apologies for that. One of the questions that's come through in the Q&A, I'll start with that one. I've got a couple, so hopefully we have time to answer it. It's actually on one of your last points there, Devraj, around the OEMs or around working. So one of the points which came through in the comments were that manufacturers are possibly pushing back on V2G, possibly because of batteries on vehicles are designed more for traction and not power plants, so this could avoid warranties. Again, this is probably quite a technical question, so I'm not sure I can answer, but maybe I'm not sure if you've spoken to manufacturers and have a point of view on that at all.
Yeah. So yes, this is a very valid point. However, I would like to remind you that when it comes to battery degradation, you have many different types of degradation, and one of the key types of degradation is what is called calendar aging, and that is just the aging of the battery if you leave it at 100% for a month or two while you're on vacation. And that's one of the types of degradations which is actually improved when you do V2G, because when you're connected to your charger and connected to the grid, you do not remain at 100% for a very long time because you're doing V2G. In addition to that, I would like to let you know that most OEMs have strategies that measure the state of health of the battery pack via some patented methods, etc. and they are monitoring what's happening to the battery, and perhaps there may be some times when V2G capabilities are limited. It could depend on the usage profiles of how users are using it. It could depend on the conditions, what the battery has been doing in the last 1 hour or so, etc. So it's a valid point that there are some use cases or conditions where V2G may cause degradation of the battery, but it's also a valid point that there are other use cases where V2G actually improves the life of the battery. So managing the health of the battery and doing V2G at the right opportunities will actually give you a situation where your battery will last longer and not shorter. And the OEMs will, there are some OEMs, which I will not name, which have like some fixed amount of hours to do V2G, etc. And then once you are done with that, you are no longer allowed to do V2G on the vehicle. But all those strategies are being optimized, and I can assure you that newer versions of vehicles that do V2G will not be shy of doing V2G. They will actually encourage you to do V2G in the right conditions.
Thank you, Devraj.
Thank you.
Only a couple of minutes left. Mark and Mike, any comments on that question at all?
I think it's evidence from the fact that we are seeing multiple vehicle manufacturers coming to us looking for compliance for their systems. So I'd suggest that vehicle manufacturers are picking up on this, and clearly there's a commercial advantage for them to do so, and they are offering these packages. So yeah, there's a change within that industry on vehicle to grid.
Okay, I've probably got 1 minute left, so I'm going to ask Mike a very quick question. It's on it's on the interoperability, as you mentioned earlier, about connecting these systems. So, what would you probably in 1 minute? How could you kind of summarize that on what the main thing is we need to do there to ensure all these systems and vehicles can operate in an interoperable way?
I think what I tried to cover, I think on my couple of slides, that the standards are now being rewritten in Europe. I can't talk internationally, but at least for Europe, the standards are being rewritten in line with the redrafting of the European network codes, such that for AC connected vehicle to grid, it will be possible, in conformity with the standards, to separately certify the cars and the chargers as being interoperable. But it all does hinge on the standards being complete and the appropriate link up between the law and the standards. But all the parties who are involved in these discussions, of course, have the same objective, which is to get to an interoperable situation. So I'm fairly hopeful that perhaps within 6 or 8 months, or maybe a year, we'll actually see that the standards and rules then exist for true interoperability once manufacturers can start manufacturing to those standards. At least that's my hope.
Yeah, I think we all hope so. Yeah, it's very exciting, and yeah, we've got a minute left, so I'm going to close off. And just today's been really great for me, as I mentioned at the beginning, kind of similar to that. It's like, I guess I look at things at a more strategic view, so it's great to hear the kind of technical aspects of things today around the importance of V2G, and it is coming by the sounds of it, and it's you know, a lot of work's being done to establish and try and accelerate the deployment and uptake of it. So, you know, it's great that we've highlighted how standards can support that, but I think one of my key takeaways is how we all have to work together collaboratively here to realize the benefits and look at the positive outcomes. And there will be challenges along the way, which we can all work on together with this. So firstly, thank you to all of our speakers. We really do appreciate all of your time. It's been really informative, you know, a really, you know, a good set of speakers covering different aspects, from government to manufacturers to the energy side of things. So really covering a lot of areas there. And yeah, unfortunately, we haven't had much more time for questions. We probably should have allocated more time there because it's such an interesting topic. my email address is there. Please feel free, anyone on the call. So thank you also everyone who's joined online. That's my email address there. Please feel free to drop me a note if you have any questions. We'll look back at the chat as well, any questions that we possibly haven't answered, and we'll try and get to them individually. And just lastly, it's our net zero week, BSI's net zero week next week. So my colleague Andrew has just put that in the slides there on some of the topics that we'll be covering. So yeah, please do have a look at that, and the links for them will be sent afterwards in the slide. So again, thank you all. Thanks to the speakers. Thanks to Andrew and our admin staff. And yeah, thank you all for joining. Hope you enjoy the rest of your day and the rest of your week.